So, hello and welcome to the first episode of the AwesomeAlgo podcast. Today's guest is Cosimo Bassi. He is a solution architect from Algorand, and he is here to essentially talk about some development best practices in that chain. And I did some due diligence to prepare for this episode by rewatching some of the latest Algorand Consensus Conference keynotes and as well as Cosimo's keynote on Algorand efficiency. I highly recommend to our listeners to check them out. I think there are some really amazing features coming in addition to existing capabilities to the Algorand chain. And with that, I suppose let's start our episode. First of all, Cosimo, thank you for being here. It's a great honor, and I think it has a great symbolic meaning that the first guest is actually an actual engineer from Algorand to talk about the topics here. And so, yeah, tell me a bit about yourself, how you got into engineering in the first place, and we got plenty of time per section, so please don't feel constrained or rushed to answer any of those questions.
Sure. So first of all, thank you for inviting me. I'm a huge fan of AwesomeAlgo since the beginning because I think it's an incredible tool that represents the ethos of a community. So very glad to be a contributor there, and thanks Hal for setting that up. So like I said, first of all, maybe let me introduce myself, talking about where I come from. Maybe because, like, I know Hippocrates says, we are what we think, we are what we eat, and where we live. So maybe, like I always say in my short bio, my roots are from Puglia, which is a southern east region of Italy, and my heart is from Pernambuco, which is northeast of Brazil. So I speak Italian, Portuguese, and English. So I'm a bit of a mixture. So
Interesting.
from each place, I think I inherited something, like from the culture of essentiality, simplicity of Puglia, maybe the fact of having creativity to find solutions with limited resources. And creativity is something that characterizes Italian culture, and I think this applies to software engineering as well. And from Pernambuco and Brazilian culture, I think it's important to remark, to feel that we are human, and there is a song that says that although we work with technology, we are human after all. So it's important to remark that, not to be alienated by technology. So I am an electrical engineering. I start my academic background studying at the Politecnico di Torino, which is an impressive public university in Italy. And I always like to remark, like a joke, electrical and not electronic. Our young cousins are a little different, because electronic engineers usually they use electromagnetism phenomena to generate, transfer, and store information, while as electrical engineer we use the same phenomena to generate, transfer, and store energy. So different order of magnitude, but same working principle. So after my studies at university, I started working as in automotive field 10 years ago on electrical powertrain. At that time, it was not obvious that, or taking for granted the fact that we would end up embracing this energy transition. So at the time was there was some doubts, maybe vested interest, so maybe some ignorance. But now we are, I think, in a good path to electrify our transportation system. So what I learned from that experience and somehow what is the inheritance that experience gave me into the blockchain. So at the time I was working in a job field that is known as system control engineer. So about system control theory. To make it simple, it means that you deal with complex systems that are described with differential equation in the domain of time, and by some very powerful mathematical tools like the Laplace transform, you can describe those systems with algebraic
So
equation.
yeah. So I guess things like linear control theory, nonlinear control theory,
Exactly.
and a bunch
Exactly.
of different. I must say that I also come from a slightly different background, actually. So yeah, it's really nice to see fellow electrical engineers. But yeah, please go on. This is really interesting.
Yeah, and so with this algebra, with very powerful algebra, you can actually build algorithms and or transfer function we say to force a complex system to behave the way you want. In that case, was an electrical powertrain. But doing so 10 years ago in automotive mean that I had to face problem with embedded electronics, because today, maybe on our more modern cars, we have plenty of computational resources. But at the time, I had to work with limited computational resources, very basic data types like integer bytes, maybe fixed point math.
So I
And
guess these are like industrial controllers, like PLC controllers, microcontrollers.
yeah, yeah, exactly. Yeah. So very, very far from the unlimited computational resources that someone has on
Yeah.
cloud. And most of all, I was dealing with software that faced mission critical software, because if something went wrong, I could damage someone physically, which could be a catastrophic outcome. So the question is, what does this have to do with the blockchain at all? I think that smart contracts somehow face some similar problem, because you program in an execution environment that has no infinite computational
Compute, yeah.
resources, and you have also limited abstractions. You do not have very complex data type, and you have also to program with a mission critical mindset, because if
Because you could
something,
lose millions of dollars if
yeah,
it's a DEX, and we already have cases like that, but that has been
exactly.
happening, and yeah, the stakes are
we,
really high
we
in this case.
Yeah, we guys in the field, we all know what could happen and what can happen. So here, if something goes wrong, you can hurt someone financially, which could be also a catastrophic outcome as well, maybe. So from that first engineering experience, I believe this is what I learned, and what I'm proud of today, because I can really find this mindset and this way of thinking about software engineering in blockchain. Then soon after, I switched from the automotive field to the energy and automation field, working with distributed energy systems. We are in the middle of a revolution, also in the grids and in electrical networks. We have power electronics, we have storage. So the point at the time was how to decentralize uh, energy generation and consumption, so that consumers are really producers and not just consumers of energy. And this approach, so decentralizing a very centralized system, immediately drawn my curiosity over other technological layers, because the problem at the time was how to make the energy a liquid asset, so more liquid, more transferable. And when I discovered for the first time blockchain, and I guess like all of us, it's maybe related to Bitcoin. At the time, I was amazed, and I said, okay, this could be a
What
really
year is this, by the way? I guess we're talking about like early 2010, 2011, or
yeah,
maybe
well,
even
it
earlier.
was 2016 at that time for me. Yeah, 2016 at that time for me, and a bit late if compared to the very beginning, but still not too
Well, I'd
not.
say 2016 was a good year because it was right before the spike and this huge sort of bull market that was in 2017 when Bitcoin first
Yeah,
hit 20K. So I think
yeah, I
it,
was not so brave enough to invest at that time. I was just an engineer speculating on technology. I maybe regret it a little bit, but okay, it's okay. It was the initial path to the white rabbit hole.
but I must say, investing in crypto and developing on crypto is entirely different universes. It's completely different experiences, in my opinion, and I think it's a good thing to actually try yourself in both of those before you actually want to truly put money into some technology. You need to understand how it works, not just from economical perspective, but from technical perspective as well, because tech also is a very crucial and important aspect of the success of any of those companies out there at the moment, competing very heavily.
Yeah, no, I'm very conservative on this. Like I always have this engineering mindset. Understand things first, and then move first steps. So no, but it was good. I immediately realized the fact that this technology, as an engineer, as a developer, had an enormous potential.
Potential.
But being in the energy, and I have this bias towards energy consumption, I immediately realized, okay, this is good, the value are good, the potential is great, but the technology does not scale well in this way. So basically, to summarize, I found myself in a position of wanting to commit my free time in this technology, but I wanted to be sure to commit my time in the best technology. And after several due diligence, so it took me a while until I discovered Algorand. At the time, there was not even a mainnet, so there was a few limited resources, just a white paper. I remember there was this very nerdy black and white markdown developer portal. We have improved it a lot since then. And so I started publishing tutorials and examples as developer ambassadors at that time. And I coded, maybe, I don't know if it's the first full application with Python. It was a mini game called Algo Nim, very simple mini game.
Oh yes, I recall that actually. Yeah. So this was, I believe, PyTeal, right? Or I
Yeah,
think is it
Python.
SDK? Yeah, I see.
Yeah. Just with the smart signature. Well, it was just right after the release of ASA and smart contract, yeah, smart signatures.
So
So
just to backtrack a little bit, so I guess we are now in sometime in 2017 or perhaps later. You're now a developer ambassador. You started developing tutorials, making tutorials. You made one of the first games using PyTeal on Algorand. But are you still tied to the electrical engineering at that point, or you're already sort of in the process of considering to commit full time into blockchain development?
No, I was still, I had still a full-time job as an electrical engineer. I was not considering at all to have a career in blockchain, because I felt that like a passion, an hobby to commit my free time. But what happened is that someday I joined a meetup here in South Italy
Hmm.
about blockchain, and they were very focused on other technology like Ethereum and Bitcoin. But I said, guys, please can I give a speech on a new technology that I discovered that I think it's worth your time and my time? They say yes. It was in the middle of the COVID, so remote, very
Hmm.
beginning of COVID, and somehow this recording has been noticed by someone at Algorand that reached me out on LinkedIn and said, "Do you want to work with us?" And I say, "Yes, okay, let's do that." And this is how I switched from my previous career to Algorand.
Great, great. This is a really interesting transition, and I guess the most interesting or the crucial part from that story that you've had so far is the fact that you've always sort of liked this constrained environment where you have access to the compute, but the compute is limited. You have to essentially optimize for efficiency and memory as much as possible. And what do you think is the most, I guess, useful concept or maybe an approach to just design or architectural thinking from electrical engineering that you found very useful when transitioning to computer science and software engineering field, specifically within blockchain?
Yeah, so having a mindset in which, so before starting putting down any line of code, have a rigorous method to uh, build design document in which you have a clear vision of, for example, let's take a smart contract.
Hmm.
You can start listing all the methods that this smart contract has, all the variables that it should use, are that variable subject, for example, to mathematical operation that could overflow, underflow, uh, things like that are very is something that I learned in my past career. I do not say that
Hmm.
I always applied this strictly, but it becomes natural to me reasoning that in that way. Because, for example, at the time, I know that for a variable, I maybe if there was a voltage or a temperature, I had fixed point math, so I
Hmm.
had to carefully decide what's the precision. So the natural mindset was spending time thinking about the architecture and the software and the variable and state space before actually coding.
Yeah,
And
it
this is
was.
something that helped me in working with smart contract.
This is, yeah. This is certainly a great approach. Like, with the modern pace at which all the technological stacks are evolving and improving, like, it is very easy to stop appreciating the amount of resources and capabilities that we have out of the box. And you can take anything that is out there, even just Python, calculating a certain process, or just relying on the massive availability of compute power that we have right now at our hands, with just a few clicks of a button, is something that sometimes is good to reflect on and appreciate, because developers in 80s and 90s, yeah, this was hell of a different experience for people back then to write computer programs. Maybe just one more personal question regarding your background before we proceed
Sure.
to the second section on what makes Algorand special. I was wondering if you could tell to me and our listeners a little bit on what was your first programming language that
Uh,
you've learned and actually loved.
Yeah, was C.
C. That's
C.
great.
Yeah.
Great.
I remember my exam in C was done on with pen and paper, so I had to write the
The
code.
old-fashioned way.
Yeah, and writing handwritten code, so no syntax highlighter, no ID, nothing, just rubber, pen, and paper. And but yeah, C, I think it's a very very good way to learn programming, because it's not too abstract but not too low level. So it's just in the middle, and you can learn how the machine work, learn how the machine is reasoning without losing the details in the abstraction of very abstracted language. So it's been a while after my last program in C, but C has been a very, very good school for me.
Yeah, I would also highly recommend the book from Brian Kernighan and Dennis Ritchie, creators of C programming language. The official manual on the C programming language is a great resource into programming
Yeah,
in general, and
I
has
think
everything
my
you need
book
basically to master that language.
at the time my book was I think it was a Datal and Datal or something like that.
There was a lot of revisions to it, I believe, and yeah, it's quite old. I think it's like what,
Yeah,
late 70s or something like that. But yeah, it's in my case it was C++, so not exactly C, but I'd say still you could go pretty low level if you want.
yeah.
All right, so this was a great introduction, Cosimo. Thank you. I think this was certainly a an interesting choice that you made in your career, and it's great to see how you're applying the experience from the electrical engineering field towards something that on first glance could seem like a completely different domain of engineering. So we've been talking and shooting a lot of definitions and fancy terms. The thing I want to do with this podcast, though, is imagine that right now on the first episode we are on level 1. So if we had an RPG game, our character is level 1, and he's a
Sure.
generic software engineer from a different field. So it could be a full stack, mobile, backend, doesn't matter. He has no prior experience to blockchain development. He stumbled upon this podcast, and we want to build this journey together. Basically, each episode is going to level up ourselves, myself, and the listeners. So we are still on the level 1, and I believe there's a set of different concepts that we need to cover before we actually are able to answer the question of the second section. And the question is, what is Algorand? What makes Algorand special? And
Right. So we're
could
gonna
you
need a lot
start
of
with
experience points.
yeah, but I believe we could condense it to 3 or 4 concepts. I think it would be great to start with a definition of ledger. So I will give the stage to you, but just to give a little historical background into the ledgers, it actually has a lot of ties in regards to human history, and it's something that humanity used for a very long period of time. You could trace it back to ancient Mesopotamians. Then there was a double entry system, some that came out from somewhere from North Italy, I believe, in 1340 AD. And then basically the concept of recording transactions on an analog entity, which in this case, the people used stone or made of clay to write quantities on there. So it's not new. And let's take it to the digital world. And Cosimo, stage is yours. Let's start with the ledger.
Okay. So the transition from analog to digital is something is a powerful concept that I think, or metaphor that I think will be useful. So the problem is recording who owns what, But if we want to generalize the problem, so it's not transaction, so it's not just transferring property, but is actually recording on the ledger the state of a common knowledge, which in the particular case of property could be a ledger of transaction. But if we want to generalize it, is okay, this is a book with the truth, and we collectively have to write next page of the book so that everybody could write the only truthful things. So it's a really hard problem, because if you take the fact that this book or this ledger should be permissionless and public, otherwise it will be very simple to add page for a very private closed ledger. You realize that the structure and the problem to be solved is very similar to an infrastructural problem, meaning that these ledger are not just information keepers. We will discover that the things that we call blockchain are really complex infrastructure made of hardware, software, and cryptography and game theory. But let's start from the very beginning, saying, okay, this is an infrastructure and a public infrastructure, so a public good maybe. So, and we are all responsible collectively to maintain this public good, efficient, and working. So there is this common problem in infrastructure, that is an infrastructure to be a useful infrastructure. It should be secure. So if you take a road, you want to be sure that the bridge do not fall down and the people do not drive like crazy. Yeah. It's accessible. So, for example, if you take a public infrastructure like a pipeline, you do not want someone to switch off pipeline. Otherwise, it's not a public good. And then it's efficient in doing what has been designed for. For example, if you take the electrical grid, it should not waste a lot of energy to transport energy. So it should be efficient.
So we have security, accessibility, and efficiency.
Exactly.
Okay.
And we will discover that in blockchain, these properties are renamed in somehow in another way, but the core principle is very similar. So the ledger, so in the analog world, we collectively live under the law of physics. And no matter how we can be upset, we cannot change the law of physics. So law of physics are there. We can just observe and discover and describe them, but they do not care if we want
they
to
are
change
absolute them. Essentially, this is an absolute constraint. You can't violate them. So this is
exactly. So you have an easy way to put everybody on the same ground in science, because the law is there, and believe it or not, you can not modify that.
Yeah.
Okay, so in the analog world, we have, thanks to the law of physics, we have nice properties on systems that can evolve, and
such as say entropy, arrow of time, things like that.
Exactly. So a system can just evolve in one direction, and this is due to the thermodynamics. So everybody, humans, we do not need a collective entity, a single centralized entity that says this is the arrow of time, because physics provides that for itself. So we are all, as humans, aligned in the analog world in a unique direction of time. In digital system, it's not that easy to do that. Because if you take a system in state A, then you transition to state B, and you go again in state A, it's hard to an external observer that will not follow the conversation to determine the fact that the second state A came after the first one, because are very similar, maybe interchangeable. So the problem is that in the digital world and in a complex digital system, we need a unique notion of time.
Mm-hmm.
And this is something that this blockchain provides, a unique and provable hierarchy of events due to time. And the second things that law of physics provides on atoms is that you cannot cut and paste atom as you like, or replace atoms as you like.
Mm-hmm.
And in information, this is hard. And so to have a system, a ledger that is spread globally, is decentralized, we need a common rule to enforce this property. One, time, and second, nobody can copy and paste or tamper the information as they like. And we call, instead of law of physics, we call this mechanism consensus mechanism.
Consensus mechanism. So once again, just a little backtracking. So we covered definition of ledger. We introduced the notion of a goal of the blockchain infrastructure, and there is the trilemma, right? We have the three pillars. That is something that for a long time was impossible to achieve, or a lot of different stacks and companies tried to essentially see if it's possible to have a golden solution to it that could cover all of them. So after Ledger, we are now transitioning into the consensus protocol. I guess I would just quickly also mention that another definition for a ledger could be is essentially a book of transactions, a book that records different transactions, right? And this is something that I suppose our listeners could already be familiar with. I would recommend looking up on the definition of what block is, what transaction is, what state machine is. But I believe in order for us to proceed, it's more than sufficient to at least have this understanding of what Cosimo just described in regards to the blockchain infrastructures and the ledger. So consensus protocol, right? Consensus, and there are many different kinds and types of consensus protocols, right? If you were to make a short segue in terms of the types of the consensus mechanisms that Algorand is using, could you give us a little rundown of existing mechanisms out there and what is special about the consensus mechanism that Algorand is providing, which I believe is something that is the key to optimize for that infrastructure trilemma?
Yeah, sure. So we have this ledger that is organized in blocks, and these blocks are verified. So let's say that whatever is written in the block has been certified by the consensus, and we have also a proof, a digital fingerprint of the block before, so this enforces an error of time. So, okay. Different consensus protocol has been historically proposed to let a distributed system of unknown people to work together as a whole and being in harmony in a fair in a fair framework that could elect someone to speak and propose the new page, the new block, the new piece of information on the ledger, or the new state of the system, because the ledger evolves as a state machine. So you can think of a new block also as an input that takes from a certain state 0 to state 1 to state 2. Okay. The problem is, who should propose this block? Who should be elected and granted the right to speak in the system? So historically, the consensus mechanism that has been proposed found a way to require a commitment, showing a commitment in keeping the ledger safe by proving some kind of interest or some kind of work in this at the beginning.
Yeah. In other words, proof of work. For example, a lot of people may be familiar with Bitcoin and Ethereum, and in fact, Ethereum, I'm referring to not 2.0 that is upcoming, but the existing implementation. So this is examples of proof of work consensus protocols where you have to solve a very complex mathematical puzzle, essentially, to prove and be eligible to vote, essentially, for the broad proposal.
Exactly. And the more computational resources you can show to commit and you can exhibit, the more likely you are going to be elected as a block proposer. The idea was brilliant at the beginning, but in the history of technology, if you see the history of the engineering, all the engineering principle is that you want to optimize to systems that produce more with spending less resources. And here we can enter in a very hard topic to be discussed, because there are vested interests, there are some maximalists. But as an engineer, I believe that we have no counterexample of systems that evolve and impose themselves in a way that you should show to spend more to obtain the same thing. So natural way of evolving technology is optimizing for technology that consume less to obtain more. And this is exactly why proof of stake came out. Because if you think about it, it's a way to reach consensus in a way that is less wasteful. And I do not believe that wasting energy is a feature of the system, because people say, no, this is not a bug of proof of work. This is the feature that we want. We can debate this on a different podcast because it's too long to be solved here. But let's align ourselves to the outcome. What should be the outcome of the consensus protocol? Because otherwise it's very difficult to reason and compare. So the outcome of a consensus protocol should be finalize end user and useful end user transaction in a decentralized, secure, and scalable way. So what that is mean is that the purpose of this machine should be exactly finalize a transition of a state. And everybody should be aware of that in a few seconds and can verify that this transition of state is a legit transition of state. And the proof of stake basically removes the commitment that proof of work requires by showing resources as computational and energy resources, by a commitment that requires you to show the fact that you own something on this ledger. So you are interested in keeping the ledger safe because you have something to lose.
Stake in it, yeah. You basically
Exactly.
You're going to lose some money, or it could be some potential resource. So essentially, you sort of invest and put a stake into it. And, this is something that's supposed to incentivize your decision making to stay truthful.
Exactly, because these systems are a combination of information technology, cryptography, and game theory. It's like a communication protocol. It's like the TCP/IP that can work if and only if it has some economic value. Otherwise, it doesn't work. So the economical value, is a necessary feature of this consensus mechanism or protocols. And there were different ways of requiring people to show commitment as a stake historically, like delegated proof of stake, because people can say, okay, I have a little tiny fraction of stake, but the barrier to the entrance are so high, maybe, that it's more worth delegating my stake to someone that can aggregate power over the ledger to be elected. And this has been done also because it's very difficult to orchestrate large consensus among several nodes. So delegated proof of stake, it's a shortcut, I think, to reach consensus, because you say you have 21 validators, and these 21 validators are the only allowed to propose the next page of the ledger, although their stake has been delegated from someone else. And the problem with this approach is that since you know the nodes in advance, it's very easy to target those nodes with denial of service. Maybe it's like playing Battleship, knowing in advance the coordinate of the ships of your adversary. That's why.
Or if we take an even higher analogy, this is basically how, well, most democratic countries operate, right? You have politicians, and they make decision making. People delegate decision making to them, so you know who to target if you were to do some malicious work, basically.
Yeah.
And for a little recap here, for people who maybe spaced out a little bit while listening to this, we covered the topic of the consensus mechanisms. We talked a bit about the proof of work, and now we are essentially doing a breakdown of the types of the proof of stake consensus mechanisms, and this is slowly leading us to the consensus mechanism that is specific to Algorand, and we're going to talk a little bit more about the approach there and what makes it special, essentially.
Yeah, and so these forms of consensus has been criticized because ended up being really centralized somehow. And we cannot make a discount on decentralization because otherwise we lose some of one of the fundamental properties of this infrastructure.
Exactly.
And so the problem seems to be unsolvable until, I think, Silvio managed to propose a very, very elegant architecture that is so elegant that is easily understandable also by non-expert at all. And the clever idea is that if you have a stake in this system, you should not delegate this stake to someone else, and you should not bind the stake locking that your liquidity, because this will create economical barrier to the entrance of this consensus mechanism. So the problem was, can we have a proof of stake consensus mechanism that is at the same time secure, so not knowing in advance the nodes that are going to validate the block, can be decentralized, so even me with a tiny fraction of stake can take part to the consensus protocol, and scalable, so this can work in matter of seconds and not dozen of minutes, and requiring requiring low energy consumption. And this is the key point of Algorand. So the key point is that Algorand is not scalable, decentralized, secure, and then efficient. But Algorand is efficient, and so it's scalable, secure, and decentralized. So a computational efficiency is the very fundamental working principle of Algorand. And then we managed to be scalable, secure, and decentralized, because the clever idea that Silvio had, and I, like an engineer, I always like to make this example. In classical engineering, in thermodynamics, you have this concept of Carnot machine that says that no matter how you cleverly can engineering a thermal machine, there is an upper bound of efficiency that you cannot break. And Silvio somehow managed to do a leapfrog toward this computational efficiency that, given the property that you want, and a good trade-off between security, scalability, and decentralization, he managed to find, for me, at time of speaking, the most efficient way to get this property together. And the key point was an idea that he developed over time, which is verifiable randomness, or verifiable random function, which is the heart of Algorand.
Yeah. Could you tell us a bit more about the specifics of this consensus mechanism?
Yeah, sure. The idea is that, okay, everybody has some stake on this ledger, and you can think, and we call these native resources algo on Algorand. And you can think each unit of algo like a magic cryptographical dice that you can roll in a distributed global dice roll. And the magic, we call that magic, but it's it's cryptography, it's mathematics, somehow gives to these awesome dices some properties, which are, you cannot tamper the result of the dice roll. So by no means, also if you have the computational power of a nation state, you can unbalance the dice so that maybe the phase number 6 comes out more frequently than phase number 4. As an observer, if you keep observing this randomness, you are not going to learn nothing, and you are not increasing by any chance the probability of guessing the next result. So it's a very, very pure randomness. And each dice is signed by its owner. So if I own an algo, I can sign the fact that this die is mine. And the other very interesting property is that once I roll this die, everybody in a matter of microseconds can verify that Cosimo rolled that dice and obtain 6 in this time. So it's a randomness that is easily verifiable. The idea is take this mechanism to implement a fair way to elect the next block proposer without requiring wasting energy or computational resources. And then using again this mechanism to elect a committee that verify what I propose is consistent. So for example, if I have been elected, I propose a block which represent the transition of the state from 0 to 1, meaning that the transition of the state could contain an update balance for my tokens, an update of a variable of a smart contract. But whatever I propose is then counter-verified by a committee which has been elected at random with the same mechanism. And everybody then gives an opinion. Okay, this block it's good or is not good. And if we reach quorum, the block is appended to the chain and is immediately final, which is impressive because other blockchain requires several confirmation of blocks before you can be sure that that modification is good. In Algorand we call that instantaneous finality. And this is the very powerful feature that makes Algorand a network that can confirm blocks in few seconds with a throughput of thousands of transactions. Today we are at 1,000 transactions and we are going to scale up to 6,000. And yes, and basically made this public infrastructure the best infrastructure to solve the trilemma.
This is really amazing approach to consensus mechanisms for the people who were listening to us so far. Just to recap here, basically what Cosimo was saying in regards to the focus on designing this blockchain with efficiency in mind as the core priority, as the core sort of capability of the chain is something that is also a big contributor to features like instantaneous finality. And if you look at the other things that were happening in the industry of the past years, ever since there was a stronger push towards greener technology and carbon negative emissions, there were certain techs and stacks that had the energy efficiency as sort of a sidecar, something that was implemented to tamper with this requirement, as we live in a world where there's scientific evidence on the warming and that the temperature is rising, and we need to work on the carbon offset on the mass scale. And so in case of Algorand, this was something that was basically figured out since day one, because efficiency was the core priority of the chain. And as you can see here, in combination with the consensus mechanism, which, to expand on this, I believe is called pure proof of stake, we have a really efficient infrastructure that solves the trilemma. I hope this is sufficient amount of information for you guys to listen to it and start researching on this a bit deeper. But me and Cosimo are going to move on due to the time constraints that we are having. But perhaps as a final question for this topic, so we covered a lot of important aspects and a lot of important concepts here. We covered the ledger, transactions, blocks, different types of the consensus mechanisms. Now, what is Algorand, right? Algorand has different meanings. Algorand is a company. We have Algorand Inc., right, which is the company with the core developer team who are the geniuses behind the amazing features and capabilities going on. We have the Algorand Foundation, and then we have Algorand as the blockchain infrastructure. Perhaps in this particular case, could you talk a bit about the organizational aspects? What is the difference, for example, between Algorand Inc. and Algorand Foundation?
Yeah, so the Algorand Foundation is the steward of the algo and the specific of the protocol. So the very high level theoretical idea is like it's like imagine an open source foundation like Linux Foundation. So it's the steward of the ecosystem. The Algorand Inc. is a technological company that has an implementation mandate from the foundation to actually translate this wonderful idea into tools, technology, documentation, libraries to fill the gap between the theory and the practice. So to deliver to developers, engineers, and builders the tools and the infrastructure itself to build on and work. So this is basically the idea.
I see. So now that we can finally talk about Algorand, and by Algorand in this case, I would be referring to the blockchain and its capabilities. Tell us a little bit about layer one, right? And so for people who are not familiar with this terminology, this in this particular case would be referring to the core set of the capabilities that the infrastructure provides out of the box. So, for example, in case of Bitcoin, the main capability there is the transfer of value, right? It's a decentralized way of transferring value on the example of Bitcoin itself. In case of Algorand, though, I suppose we could have a closer analogy to chains like Ethereum. So it's not just the transfer of the token itself, the Algorand Algo token. There is more to that. Could you talk a bit about the most notable features that the Algorand blockchain provides out of the box?
Sure. So it's very important to remark that all the features that I'm going to mention are built on layer one. And maybe we can expand a little more after on what does it mean. But basically, Algorand provides out of the box features that can be fully combined between themselves to build very complex kind of decentralized application. So Algorand is an account-based blockchain, and each account could be controlled by regular private public keys. So the first feature is having an account and having a secret key and performing your actions. This account can be also controlled by several keys. So another interesting feature is on an Algorand, you can have multi-signatures. So you can have account to really share your decision-making between several parties. But you can also have an account that is controlled by a smart contract, which is very powerful. So in Algorand, we have this execution environment that is built on top of the layer one that we call Algorand virtual machine, that basically is an execution environment that a trustless execution environment that can perform computation in a Turing complete way. So it's a Turing complete machine that can execute code to operating and computing on inputs and giving you output that can be stored on the ledger itself. And to combine these together, so imagine this very powerful execution environment, different kind of accounts that can interact, humans with smart contract with smart contract. In Algorand, we have another very interesting feature that we call atomic transfer or group transaction, which is a cryptographical glue to combine together different interaction on very complex multi-party transaction to be sure that either all the effects are satisfied or nothing happens. So imagine to have different smart contract and different human beings that should cooperate to accomplish a very complex transaction or update of the state of the system. But you do not want to expose anybody to counterparty risks. So you do not want to a smart contract go first and then you go after, or the other way around. Algorand allows you to combine all the transaction together and make sure that the effects are instantaneously reached together or nothing happens. So in a trustless way, we can cooperate in a very, very powerful way, building very complex interactions.
So we have a set of transactions bundled in an atomic group. If any of the transactions do not satisfy the condition of the smart contract, the entire transaction could fail. So we could, for example, take a simpler analogy. Imagine that you are going to a cinema with your friend and you're about to pay for the tickets, and you're paying for your friends with your money, and then your friend needs to send the amount that he owes you. And an atomic group could actually allow you to let your friend pay the money to yourself for the amount that you're about to pay to the cinema. And all of that can happen in an instantaneous single atomic group with finality of 4.4 seconds.
Exactly. And if you think about this, is very, very powerful, because you can obtain together the effect of several smart contracts, and the capability of the smart contract in Algorand are very, very impressive. For example, smart contracts can create transactions, smart contracts can call other smart contracts to ask for results of a computation. They can read other entities, like they can access the information of an account, they can read another smart contract. So you have several actions that can be executed in a block. Somehow those transactions could be unrelated, so there is no problem in losing atomicity. But in other case, you want to orchestrate these very complex effects together, and this is where the atomic transfer really helps. And talking about smart contracts, and a new feature that is going to be released is what we call boxes. So today, the amount of memory that you have in application is divided between two kind of memory space. So each application has a global memory, which is common to everybody. So to all the participants of the application of the smart contract share this global piece of memory that is controlled by the smart contract. And you have another piece of memory which is global, but maybe records a variable that belongs to specific user participating in the decentralized application. With boxes, we are going to improve and extend the amount of memory that globally the application can consume on chain. And you can pay as you go. So you can allocate memory as you need. Because today you have to pre-allocate memory. So you have to do your math and you have to say, okay, I'm going to need this amount of memory, but you don't really know how to scale up. With boxes, you can do that. And this is a nice feature that we are going to add to the layer one.
Yeah, for many developers out there who are already familiar with the Algorand development, I believe this is a common pain point. A lot of people, especially projects that do gaming on Algorand blockchain, there's a lot of edge cases when you essentially need a smart contract to have enough space to, let's say, if you have a game, an RPG game, and you want to have a backpack with a lot of swords, right? You have to extend the amount of storage available globally to sync the state and to allow for different customizations. And this is one of the ways how, once again, something that is going to appear as a capability out of the box, and it's going to enhance on the existing features that stateful smart contracts provide. I'm a little bit curious on the implementation side, though, in regards to the box storage. For example, in my case, whenever I need a storage, and we are talking about the Web3 space, an easy example could be to rely on some IPFS provider, right? Like Pinata Gateway, or we have the Web3 .storage that provides like 1 terabyte for free on a free plan. Of course, with IPFS, everything is public, so you shouldn't store any secret information in there, but it's usually a pretty easy entry point if you just need a quick blob storage to store some text file or configuration file. But in case of Algorand box storage, is this something that purely relies on the compute capabilities of, let's say, AVM, or it's something that works in tandem with some already existing Web3 technology? In other words, what is the storage in this particular case? where does the data get to? And let's say a person adds a new box to his account.
So the concept of on-chain memory do not change that much, in the sense that it's not because of boxes that Algorand is going to be a storage layer. No, we should not somehow conflate the two different roles. But with boxes, you are going to be able to improve your computational capability, because you have access to on-chain memory, although this is not intended to be a repository of files or EV information. So the role continues to be very similar to the role that on-chain memory has today. But the next feature is that it's dynamic. You can allocate that memory as you need, and basically this solves other problems of scalability, because today, to scale up memory, we rely on the fact that if we have 1,000 users in an application, we can rely on the fact that we have 1,000 pieces of local memory to play with. The problem is that since the memory is local, it's right and fair to say to user, you are the owner of the local space, so you can also choose to opt out the application, and the local state is gone. So with boxes, we have a way, for example, to store information related to the users, and we can scale up, preventing the user to delete this information, because the on-chain storage cost is backed by the application creator itself. So, for example, if you have an application in which a variable represents something negative to the user, maybe a debt, you do not want to let user cancel the debt as they wish. But you want to maintain scalability because you maybe want to track debts of thousands of users. And Box is a way to do that.
And do you need to rely on a stateful smart contract in order to use this feature, or it's something that could also be applied to smart signatures? And
No,
for the listeners out there, smart signatures was a way to call stateless smart contracts before, right? The terminology was that we have stateful and stateless smart contracts. Stateless are just escrow accounts that execute the logic without an implicit state attached. And stateless, by definition, is something, as we're talking right now, it has a storage. We have global storage, we have local storage, and the upcoming Box capability will allow us to essentially worry even less about the amount of storage that we have. But sorry, yeah, going back to that question. So is it a capability that is specific to the stateful smart contracts in this case?
Yeah, right. Because the Algorand virtual machine has this architecture that is splitted into hemispheres, in the sense that if you have the source code, the ETL source code, which execute computation on a stack, this source code can take inputs from two different worlds. The transactions that call the source code itself. So the inputs are inputs that come along with the transaction. So there is no previous information, you do not access memory, and we call this stateless execution. Or if you want to access information that have been recorded previously, so that exists independently from the fact that the transaction is created, you are dealing with stateful execution. And yes, boxes are going to deal with stateful execution.
I see. And another interesting thing, and sorry, by the way, just a quick remark. Cosimo mentioned word teal. So for listeners out there, teal is a language for developing smart contracts on Algorand. It has, I would say, a rather different approach to if to some other blockchain ecosystems such as Ethereum, where, for example, Solidity is closer. It's more like a C-like language. It's the transition there is easier, but in case of Teal, I believe, which I suppose could be simpler to understand for people who have some basic understanding of what assembly is, but luckily there is a lot of development going on in that space, so that developers have to worry less and less about, actually dealing with the native Teal code, and there are different transpiling frameworks that allow you to write in the programming language you're comfortable with, and then that gets transpiled into Teal code, and this is something that will actually go into a call that sends the code to the Algo node that then compiles it for execution. Another interesting thing, and the focus that Algorand is doing right now, is the fact that you, as a company, Algorand doesn't say that we want to be the leader, we want to be dominator, we want to be benevolent in the space, and we are going to crush our competition. Right? There is a really brilliant approach in the sense that you guys also understand the importance of other chains. Right? Maybe, okay, there won't be billions of different stacks in the future, but there would be a subset of technologies that will outlast and will survive and will provide essential value. And they would need to somehow communicate between each other. So I saw that with the recent keynotes that were announced recently, along with the block storage. One of the long, I would say, awaited features that is coming is the state proofs. And I know that there is a lot of theoretical material that would need to be covered to actually go do a deep dive there. But if you just briefly cover a little bit, what are state proofs and what is so special about this feature, and why Algorand is currently actually putting a lot of focus on that particular area?
Sure. So, as I said, we believe this world is a multi-chain world. So the reality is complex, and we cannot pretend to be a single source of computation and truth for the whole world. So we have to cooperate, and we have to coexist with other interesting technologies. And the problem is that two different blockchain do not know each other well. So if I have a blockchain A and a blockchain B, somehow there should be someone that read blockchain A and says to blockchain B what happened, for example, on Algorand. Because imagine that I want to take action on blockchain B based on the fact that Cosimo on blockchain A executed a smart contract. But blockchain B itself is not aware of the external world. So imagine two different universes, and these universes are not communicating. So we need a way to let the information flow from universe A to universe B. The solution that people found historically to this problem was intermediating this information flow with technology that we call bridges. So someone or a committee or a small network of other nodes that have the duty of reading blockchain A and informing blockchain B. The problem is that it do not make sense to improve consensus mechanism the way Algorand did, to then rely on centralized or less secure way to communicate Algorand generated information to the outside world. So the key point is, why not to use our consensus protocol to validate our state in a convenient way that is understandable in an efficient way outside. So state proof is like a way of Algorand of taking selfie of itself. So it's a snapshot of its state.
That is taking every, 15 minutes or something like that? Or
yeah,
there's a fixed time interval, basically, yeah.
Exactly. Imagine Algorand as a way, a state proof as a way of taking regular snapshot of Algorand. And the beauty of that is those snapshots are generated the same way the blocks are generated somehow. So there is the same level of security, decentralization, because it's the consensus protocol itself that validates its own state. And these allow to Algorand to produce very, very compact certificates of the state that anybody outside can read and understand. So somehow state proof, which is another layer one feature because it's produced by the consensus protocol itself, is a way for Algorand acting as an oracle of its own state to someone else, where this someone else could be another chain, maybe Ethereum, that maybe want to know something about Algorand, but this someone else could be a node runner that want to join Algorand. Because in this way, a node runner that joins the ecosystem has two possibilities. If you want to remove any kind of trust in the Algorand system, you can say, this is the software of the node, this is the Genesis block, you can re-verify the whole history of the chain. Good luck, it will take some time, but you will end up knowing the same state, the present state that everybody knows without trusting anybody. But if you can admit a little amount of trust, which is the trust in the working principle of Algorand itself, you can say, hey, Algorand give me this snapshot and says, trust me because this has been generated by the consensus protocol. This is the snapshot of the state at block 20 million. You do not need to re-verify everything again. Start from here. So state proof are also a nice way to let people join Algorand easily.
Yeah, because you essentially, as you said, don't need to run through starting from the Genesis block. You could skip certain iterations. You run over those snapshots, and this speeds up the time it takes for you to basically sync up with the latest state. And if I'm right, there is also a notion of something that I believe is pretty actively being discussed for the upcoming Ethereum 2.0, but the notion of the snark proofs, which I believe in this particular case, and once again, we don't want to go too deep into it, but a snark proof is kind of like a meta proof that says that, okay, I don't know, like I'm not providing you the state proof, but I know a state proof that with a certain probability could say that, okay, there's a majority of the network that actually approved the validity of the state. And once again, going back to the consensus mechanism, anything you could add a little bit on the snark proofs and what could be, I guess, a great use case for it?
Yeah, so this technology is a technology that allows us to shrink the amount of information that you need in order to read and parse the state proof that Algorand generated. Because imagine if the state proof generated is big, it could be hard for other blockchain that have also limited amount of computational resources to read and understand and verify the proof itself. So the problem is not only generating proof, but generating proof that can be conveniently and efficiently understood by someone else. So snarks, ZK snarks, are a way to shrink and collect signature and shrink the amount of information without losing properties of security about the proof. So it's like a compressing mechanism to allow also a very small light client that runs on maybe on an Ethereum layer with a smart contract to be able to understand and verify the proof.
And just to clarify for the listeners, ZK SNARK is actually an acronym. It's not something that mathematicians came up just for the fun of the way it sounds, but it stands for Zero Knowledge, Succinct, Non-Interactive Argument of Knowledge. So I guess you understand why it had to be converted into an acronym, because pronouncing it every time in a paper or in a podcast would be torturous. So for the sake of time, let's move on with a bit more dev specific topics. I know we are going a little bit over time, but I think there's a lot of
No problem.
really interesting material that we've covered, and I think it certainly made sense for us to stop on them and cover them in a bit more detail. But moving towards the development ecosystem. So for people who, let's say, have certain exposure to Algorand ecosystem already, and for people who don't have any exposure there, this would be the final question of this podcast. We would briefly touch base on what advice would we have for people who want to basically get their hands on blockchain development on Algorand. So one of the things that was somewhat of a struggle in the early days when the ecosystem just started expanding, but this was for some engineers, we could say that this could relate to the learning curve of the Teal language, right? I believe things like PyTeal, for example, weren't instantly available in the beginning. All of those are open source framework that Algorand maintains. And we haven't mentioned this explicitly, but by the way, Algorand is open source. So you can read the white paper, you can open the GitHub organization and see the implementation of various mechanisms that you could also see and have some supplemented material backed by theory. But the notion of dealing with smart contracts for any engineer who just getting their hands on blockchain development there's a learning curve basically, and it's not necessarily an easy process. But what's even harder is having an infrastructure that allows you to easily test them, right? And when we talk about Algorand development in 2022, so this is what we are in June 2022, there was a lot of packages and frameworks that has been developed since then, and they keep evolving and expanding. But what would you say is a great recommended testing stack for smart contracts on Algorand? And we can make a breakdown for two groups. So for small and medium organizations, and let's say it's a large scaled project with high stakes like a DEX or a bank or something that would basically from day one would assume that it will support a large audience.
Yeah, sure. PyTeal, first of all, is a great abstraction of the EVM because, like I said, the Algorand virtual machine can be programmed in this low-level language that we call Teal, and then on top of it, you have this library that we call PyTeal that lets you program in Python. But if you face the problem of developing a smart contract, you are going to deal with different tools that Algorand provides. Because remind that the Algorand network exposes APIs that are then abstracted and wrapped in what we call SDKs. So that are delivered in JavaScript, in Python, and in Java. And so to execute the natural feature that the layer one provides. This is one part of the interaction with the network. The other part of the interaction is actually programming the virtual machine. So let me state clearly that in Algorand, it's not always the case that you need to program the Algorand virtual machine. For example, if you are new to blockchain and just want to create a token, The fact that Algorand provides tokenization as a framework on layer 1 means that just with an API call or a single line of Python SDK, you can obtain a token. And this, in this kind of very first introductory application, testing will be much easier because you are not going to deal with programming the smart contract itself. But when it comes to having your hands on the Algorand virtual machine, I can recommend. This is my stack. This is I'm going to talk. I'm going to talk about my usual stack, which is not the mandatory. It's just a stack that I found useful for myself. But feel free to explore others if you like. So basically, my usual stack is a Python stack. And the environment to run, compile, and execute testing that I usually have set it up is through the Algorand sandbox. So the Algorand sandbox is the first piece of the stack that you should be aware of, because it's a way to create a micro Algorand network with just yourself inside. And this allow you to use what we call the sandbox in dev mode. So imagine you have this Docker container that runs locally, or could be also integrated in your continuous integration pipeline. And if you run this sandbox in dev mode, you have a complete Algorand set of tools without the latency of the consensus protocol. So imagine that although Algorand has a few seconds of latency for generating block, if you have to run a bunch of, 100 unit tests against a smart contract, this could take a while. So sandbox in dev mode, it's the first piece of the stack that you should use. Of course, working in Python, the Algorand SDK is a very powerful tool because allow you to create accounts, token, multi-signatures, atomic transfer just with few lines of Python. And then the very powerful combination in PyTeal is that in PyTeal you can code a smart contract with a Python expression that then are compiled down to Teal and then compiled down to bytecode, essentially. And my usual setup is this way. So I start with a design document that lists all the method of a smart contract. And each method of a smart contract can be permissioned or permissionless. For example, permissionless means that everybody can call the method. Permissioned, just some account can call this method. So first of all, when you have these two cases, permissioned over permissionless, when you are in a permissionless way of executing a method of a smart contract, you should list all the preconditions that you may want to verify before approving or rejecting a smart contract call. And once you list the precondition, you can then list the effect that method should apply to the blockchain, like transferring a token, creating a token, updating a variable. Having all the preconditions listed is useful because you can test each of them. And I usually recommend a testing framework like PyTest, which are very convenient to create unit tests because you have these concept of fixtures or test parameterization that allow you to be very repeatable. So imagine that you have a list of, 3 preconditions that should be met in order to approve or reject a transaction. It's convenient to write proof for each scenario. So for example, if you expect that this particular transaction is rejected, create a transaction that is rejected and actually prove that your smart contract is rejecting the transaction. Or if you want to test your happy path because you expect this transaction to be approved, build that and throw that against the smart contract and actually verify that the transaction is approved. So for each interaction that the smart contract has that requires some precondition, build unit tests. And PyTest in combination with the PyAlgorand SDK and PyTeal is a very flexible environment to build very specific tests to cover with a lot of flexibility any scenario of smart contract execution. And the last resources that you have to debug a smart contract and to test is the TIL debugger. So suppose that you want to test the happy path and you were expecting this transaction to be approved, but turn out that it's rejected. So there is something that is not going wrong, going right in the source code itself. So you want to verify where the smart contract is not behaving as you expect, and you want to execute the source code line by line. The TIL debugger is a tool that you have that works in this way. You take the transaction that is supposed to be approved, and you dry run this transaction against the present state of the chain. So you take the state of the chain, you dry run it, and you get the result of a transaction that is not actually committed to the chain, but is represented in a JSON file that will behave as if it were committed. And I code for myself some utilities, for example, to automatically write the dry run transaction with try catch on transaction failure to speed up the generation of the dry run requests to be submitted to the TIL debugger. And once you have this dry run, you can invoke the TIL debugger that open up the Chrome debugger that actually allows you to execute line by line the code of the smart contract. So again, to summarize, build a design document for your smart contract, list all the methods, list all the precondition for each method, build unit tests for each precondition, and if the test does not behave the way you want, the last resource is the TIL debugger.
And to expand on this, when you're mentioning the specification for the smart contract to be defined, or in other words, let's say we basically write a requirement for all the expectations that we have from the contract that we are about to write. Are there any standardized templates or perhaps conventions that Algorand provides in regards to designing the smart contracts, or in this particular case, this is your personal preference and just personal approach that you like to do? Like I understand the notion of creation of the requirement file. Just curious, if there's anything out there in the open source ecosystem that attempts to templatize or standardize this particular document.
Sure. So recently I worked on a reference implementation of what we call Smart ASA, and it's not public yet, but it's going to be published. So in that case, the reference implementation is based on the design document, which is the ARC20. So you can start thinking taking the ARC20 like the first step for a design document for a project, in which you state all the interfaces of the smart contract and describe the expected behavior of the smart contract. And the ARC20, for example, has been built with the ABI standard in mind, which is a very, very convenient way to standardize smart contract method calls and define signatures and define the interfaces in a JSON file to let people understand how to call the smart contract. And when we are going to release the reference implementation, you will see that guideline, which is described in the ARC20, is then has been implemented the way I described. So with PyTest, unit tests, client, PyTeal implementation, and maybe you can have a journey in that source code to. It's not the Bible. It's not. But it's the way I found most reasonable to translate the reference doc, which is the ARC20, into a reference implementation, which is well tested. So once we release this, what we call Smart ASA standard, you will have also an open source template or maybe example of the concept that I was describing.
And for listeners out there, especially with engineering, software engineering backgrounds, ARC in some senses essentially Algorand's take on RFC documents, so something that you may be familiar as request for comments documents. It's something that has been utilized for a very long period of time, I believe since 90s, and as Cosimo just described, there would be examples on how you could implement some of these design specs for yourself while developing the smart contracts.
Yeah, and sorry, go ahead.
I just wanted to make a little analogy here that some more experienced developers could say that we have things like Algo Builder, we have things like Reach, by the way, which is a language that allows to compile your smart contracts into different chains. So you could write a smart contract in the Reach language, and then this will be compiled to and could be deployed to Algorand, Ethereum, and different nodes. Then we also have, as Cosimo just described, PyTeal and PyTest. And going back to the analogy we had in the beginning, was the first programming language that you learned, which is C. I believe if we were to take that notion into the testing of smart contracts, this is something that I think is relatively close to that, sweet spot when we are not super low level. It's still Python, right? Python is very easy and straightforward. It has very easy and straightforward syntax. If the kids can write in it and debug in it. But at the same time, it's very flexible because it's right above teal. Basically, there's only a single transpilation that is going on. So I think irregardless of the size of your project, it's in the worst case, it's still a really nice learning experience because you are going to learn a lot. In this case, we don't say that it's an easy configuration, but at the same time, it's very flexible, basically. And Python just gives you an ability to not worry much about the setup. If you're familiar with any development stack on Python and familiar with PyTest, it is essentially nothing new. You do pip install PyTeal, you write the smart contract, you add the test folder. If you use some nice IDEs, by the way, Teal debugger also is available as a Visual Studio Code extension, and you could look up some sources on the AwesomeAlgo.com. But essentially, yeah, I think this is something that I would strongly agree with you in regards to the testing stack. There is a small time investment that you need to do to set it up initially, but once it's set up, extending it is really easy, and this flexibility that it provides to you and ability to essentially control a lot of aspects in regards to the transpilation is just very convenient. You could also see some of the examples of how this could be used on some open source projects in the ecosystem. For example, the Algo World Swapper, and thank you, Cosimo, for the contributions in there. But you could see the Algo World Contracts repository where we use the CI, and as Cosimo was describing, there's pure PyTest and PyTeal used on the repository. We have the GitHub action that spins up Algorand Sandbox, so a mini Algorand network on each pull request. And essentially, I guess it's not a unit test in this particular case, right? Because we run actual transactions against actual small instance of a chain. So it's more of end-to-end, but this certainly gives you way more confidence in whether your smart contracts is important or not. And it's one of the most crucial aspects of any smart contract development. As we said, stakes are very high. It could be a financial system, it could be a bank, it doesn't really matter. Your users could lose money. So you have to do extreme due diligence when testing your smart contracts, because that's all that matters in this particular case. Exploitation of it is often referred to the human factor. So it's just a very important aspect that you should pay a lot of attention to. Your the app should always have a very, very solid setup in regards to testing of your smart contracts. So,
like you said, there are other tools like Reach, like Algo Builder, and I will let other developers comment on that, since I am not very, very familiar with that, because I'm more familiar with this stack. But the fact that I want to highlight with the stack that I mentioned is that, for example, it's very, very flexible, because PyTeal has a nice and seamless interaction with all the Py tools that you already have out there, like PyTest, continuous integration, and it's very flexible also with respect to the Algorand virtual machine, because it's an abstraction that do not lose flexibility in using opcodes with very specific usage of the Algorand virtual machine. So it's an abstraction, but not too much abstracted so that you lose controllability over the Algorand virtual machine. And the fact that you use the sandbox actually lets you test the behavior against the consensus protocol, the real Algorand virtual machine. So there is not an abstraction layer of the Algorand virtual machine to test it. Yeah.
And once again, we're not saying that you got to use this stack. Take your time, do your due diligence yourself. There's a tool for every kind of project you could find. But our point is essentially that if you start with this stack, if you gain experience with this stack, moving on to other higher level tools such as Reach, such as Algo Builder, or anything that would be built by ecosystem would be way easier for you if you compare it with a different approach, where you would start with a high level framework that has a lot of syntactic sugar and does a lot of magic for you. And then you would try to go lower and understand it, but essentially it would be a bit counterproductive. So start with something that is very close to the teal itself, that does not do a lot of transpilation, and it allows you to a lot of flexibility. And afterwards, you could move on to basically anything you want, but you will have this essential knowledge and understanding of how things work under the hood. So we covered a lot in this podcast, because this is more than I expected. And once again, sorry for overtime, but I think this was going into various different interesting directions. There's a lot of food for thought for different audiences. Last two questions I wanted to cover. One is relatively short, still on topic of testing. And then a final question would be your advice to newcomers, actually, people who don't have exposure to blockchain development yet. One thing I just wanted to expand is, could you tell us a bit more about Graviton, which is, I believe, a project that is also currently being open sourced by Algorand. And if I got it correctly, this is a an Algorand's attempt on black box testing of the smart contracts, right? Would you say that this is something that potentially could be a nice addition to this setup that we've just been talking about with PyTeal and PyTest?
Yeah, sure. To be fully transparent, I haven't the chance yet to try the tool Graviton, and I think the colleagues that are working on it will be really happy to join a conversation on that. But
I would love to have them
basically,
as guests.
yeah, maybe I'll try to connect you. And but yes, the tool is another testing framework that approach the smart contract testing uh, in another way. Maybe it's more fuzzy oriented, like testing several in a range of variability of for example of some numerical variable. You do some more coverage because you maybe auto generate more cases. So I'm not an expert again because I had no chance to try it yet. But I think that the guys that are working on it will be very happy to comment on that.
Awesome. Yeah, like I also see that based on the availability on GitHub, this is something that is still under active developments, but essentially we could imagine that sometime in near distant future, this flexible setup that we've described, PyTest and PyTeal, um, there might be some additional tools or some additional capabilities that Algorand will be providing as part of its SDKs and tooling that will simplify smart contract testing and verification even further.
Yeah, what I can say is that today we recognize that the development experience is a bit cumbersome because you have to a bit of context switch between your IDE till debugger. But guys on product team are aware of that, and there are a lot of ongoing brainstorming and ideas over a, a toolkit, so a framework or a single command line interface to maybe put together a single unique development experience. So, for example, uh, today I found myself using cookie cutter to set up project skeleton over and over again. And then you realize that when you want to set up a new smart contract project, you have always the same path to do. So this could be simplified. So maybe there could be a single command line interface that set up a project for you with all the artifact that you need. This is something that definitely is gonna come.
And I'm sorry for going a bit off topic, but just from my personal experience, the majority of pain that I have experienced in terms of Web3 development wasn't actually something that is related to the Algorand's capabilities. And in fact, the stack that is provided out of the box is the least amount of caused the least amount of issues while dealing with the packages that Algorand provides. But I think that it could have been really amazing if Algorand came up with some sort of IRC that standardizes how different wallet client implementations should essentially write their classes. So if there was a way to standardize the interface for all the wallet clients available out there, and I'm not saying, make a killer framework that is in JavaScript and you plug and play and boom, you have Algo Signer, you have Wallet Connect, you have Parawallet working on together, because supporting this is a large investment. I don't think folks at Algorand want to waste their brain power on messing with all these different implementations. But if there was a way to propose a standard on how to write those interfaces. Then developers could actually write tools that aggregate different wallets with ease, because right now the big issue, for instance, on Algo World Explorer, it took me a few months to simply just squash them all together into a single interface, abstract them away, and make sure that everything is working. Then testing is another thing, right? There is, for example, Wallet Connect. How do you unit test scanning a QR code from a mobile phone, right? So there's a lot of flaky things within the generic Web3 protocols that are unrelated to Algorand itself that also could get the learning curve on the development a bit harder. But this was just an off-topic thing I wanted to share in regards to the experience so far.
These are the most valuable feedback for us, and because people that have work hands-on on different tools, Algorand tools provides. So I 100% agree.
And on that note, I think we also did a pretty decent dive on the testing suggestions. So now let's get to, and I'm really curious to hear if there is a person that, or a subset of people who are still listening up to that particular point. So if we have a set of listeners at that point, those are the most committed followers that we have so far. So for newcomers into the ecosystem, developers who have some exposure to web development or basically any software development in general, and they want to get their hands on what it feels like, what's the experience like with blockchain development in Algorand, what advice would you give to them?
Yeah, so transition to Web3 development, I think requires another layer of skills, which is not impossible to build. So being a developer with reasonable experience, I mean, also a beginner, do not prevent you to step into the blockchain development, because it's just a technology you get used. The more you interact with as a user, the more you interact as a developer, seems natural, the fact that you learn. So if you come from a software development background, my recommendation is really start with a small, simple smart contract that maybe just do one thing, like minting a token. Choose a stateful smart contract, because programming stateful smart contract on Algorand is way easier than programming smart signature. And start doing, maybe choose Python, because Python is flexible enough to provide you with PyTeal development experience, and just start with a smart contract that you can call by the command line. Once you have this little nice object that responds somehow to your stimulus on chain, then all the part of all the rest of the development stack is way easier to learn. So because it's more natural for you to interact with a smart contract from the front end side, once you realize what is happening really on the low level backend side of the chain, because you are going to deal with transactions that are not executed, you are going to deal with errors. But if you do not program once at least a small smart contract, it's hard to understand what's going on. So maybe it's counterintuitive, but I would recommend to start working with your single feature smart contract that maybe just mint an NFT for you. And then you will start realizing that the more you put your hands on in this development, the more you will interact with the Algorand documentation, the more you will discover, and the community on Discord is very supportive. So you are not alone in this journey. And my recommendation is keep in mind that this is a pioneering learning action for everybody. We are not here to learn from centuries of knowledge that are stored in books. We are here to build together more than learn, because you learn by building, of course. And in this field, I think it's very crucial to start working hands-on.
Yeah, I couldn't agree more with you. In fact, I would give 50% of all the help that I essentially received when facing challenging issues with Algo World Explorer implementation, were just people and enthusiasts on Discord. And it was really me just, there are certain things that you can't rely on in regards to the maturity of the ecosystem. Keep in mind, the chain started in 2019 and it is expanding like crazy. It's a very dynamic environment. So people closer to, I suppose, full stack development could actually benefit from switching to Web3, because it's nothing new in some sense. You still deal with a lot of different aspects on the backend side and the front end side. And the main advantage in this case is that you have to worry less about authentication, right? You have the accounts, you have the wallet clients. Each account is a pair of a public and private key, and that's a responsibility on the side of your user. Then you have essentially an ability to offload certain computation, right? And with addition of box storage, smart contracts are going to be able to have even bigger memory that you can rely on for the global state. So you worry less about authentication, you worry less about databases, you worry less about backend. So it really just allows you to also put a bit more focus and due diligence on the actual logic of the smart contract and your DApp. So blockchain development, in some sense, after a certain learning curve, could feel like something that simplifies a lot of aspects of development, because you simply have to worry less about the infrastructure.
Yeah, and I have some contents shared on the AwesomeAlgo repository under the learning section. So it's a personal deck that I call Algo School, that maybe could give you an overview from the very beginning until the end of PyTil deployment. I think that's a good resources for someone that is starting. So it's a deck that explains step by step almost all the tools on Algorand. And my suggestion is take that deck, read it, and then put yourself hands on the keyboard, and although it's hard in the beginning, start developing a smart contract.
Yeah, it's counterintuitive in the beginning. I also had this, the grasping stateful smart contracts in the beginning was pretty challenging. But once you get the gists, it's really just a matter of commitment. So on that note, once again, I think we reached the end of the last section that we wanted to cover with you, Cosimo. Thank you very much for joining. This has been a great pleasure. I think we covered a very nice set of different concepts that should serve as a food for thought for different people from different engineering backgrounds. I hope that by the end of the podcast, an average listener learned at least the core concepts of what makes Algorand special and what is the reason behind the AwesomeAlgo podcast. We are trying to reveal different interesting tools, frameworks, and platform in the Algorand ecosystem. And in this episode, we basically did a deep dive into the Algorand itself. We covered different features, the layer one capabilities that it provides. We covered the uniqueness of the pure proof of stake consensus protocol. We gave some advices on the testing of the smart contracts, which is a very important and crucial aspect of Algorand development. And lastly, as Cosimo pointed out, and as I pointed out in the introduction to the AwesomeAlgo podcast, the episode 0, there is a lot of great learning resources that you can find on the AwesomeAlgo website under the learning session. And of course, the official Algorand documentation at developer.algorand.com is also your entry point. I personally could say that I've noticed a lot of changes that happened over the past year. So documentation is in far better shape. I think you guys did a terrific job on also making those short little sort of graphical comics that cover different theses and topics there, and it just gets improved on a monthly basis. You certainly won't get lost with grasping different features and capabilities. And on that note, unfortunately, I cannot announce the name of the guest for the episode number 2, but we'll work something out with Cosimo a bit. Perhaps it could be someone from Algorand. There is potentially it could be Ryan. And we could, so from the developer relations, we could talk a bit about some of the higher level features, or it could be anyone from the community. If you are in contributor to AwesomeAlgo, and if you want to appear on this podcast, when you open a pull request, there is a link to the type form. Basically, fill the description there. Tell us a bit about your package or your tool, or what you're contributing to the list. I'll take a peek into your implementation, do some preparation for the agenda, and afterwards you could be invited as a guest, and we would do a deep dive. And the sessions could last from 30 minutes to, as you can see here, we went over time because it was really engaging. And so there's really no time limits as long as we agree on the right agenda. So once again, thank you, Cosimo, for joining, and thank you for listening to episode 1 of AwesomeAlgo podcast. See you later.
Thank you.